Alright, hey guys, time for lesson 11. We're going to talk about similar polygons, but we need to learn how to solve proportions. This is just cross multiplication. So, cross multiply, you ask yourself, what's 9 times 6? Good, 54. That was the easy side. This side, I'm about to sneeze. No, they were my lungs. Don't forget, 8's not only being multiplied by k, but 6 as well. So what's 8 times k? Yeah, no duh, 8k. 8 times 6? Good, 48. Again, you're going to want to subtract 48 from both sides. Basic algebra. 54 minus 8. Trick here, count up. So that's 6. And then divide by 8. So, k is going to be 6 over 8. Now we're going to want to reduce that, so 3 over 4 will be your answer. Yeesh. Let me try that again. There we go. Alright, just keep up the same pattern for the rest of this. I'm going to go ahead and pause the video, take a second to work these out, and then hit play again for your answers. Okay. Alright. So, did you get the same thing I did? Wonderful. Let's keep going. Bloop. So, here's a nice little warm-up. Again, you can pause the video, draw the pictures, and try it out for yourself. Yeah, go ahead and pause the video. You really should. Hey, now we're back. So, let's look at the answers. Bleep. So, I went ahead and placed the links where they belong. I took the scale factor, multiplied it, and we got 7.65. Pretty stinking easy. All you're doing is multiplying by the scale factor. So, given two figures, use the definition of similarity in terms of the similarity transformations to decide if they are similar. So, how can I identify similar polygons and use proportions and scale factors to solve problems involving similar polygons? Remember, the big idea for congruent is same shape, same size. Couldn't stress that enough in class. And now we're adding similarity. The idea of similarity, same shape, different size. Okay? One word changes. Right here. Same and different. Well, let's face it, it has to make sense. Congruent means they'd be the exact same. Similarity, they look the same, but just different sizes. So if you need to, go ahead and pause the video and write that down. Bleep. Again, similar figures. Two figures are similar if and only if the measures of all corresponding angles are congruent. Again, don't forget that. The ratios of the measures of all corresponding sides are equal. The symbol similar, well, I really don't even know the technical term for that. I call it squiggly worm. The symbol squiggly worm means is similar to. Notice that looks like the congruent symbol, only minus the equal sign underneath. So not quite like crispy bacon in the pan anymore. Boop. Here's your example. Again, if you got the follow along notes, we're just filling in blanks. So, in the statement of similarity, vertices have to be listed in corresponding order, just as in the statement of congruency. Can you see that in the statement in the figure above? So, what we're trying to express is angle A and angle D should be congruent. B and E are both 90s, so they are congruent. And C and F as you can see with just the one tick mark, shows that those angles are congruent. And if you notice about the side ratios, we can easily tell that the scale factor here is just multiplying by 2. So 3 is to 6, 4 is as to 8, and 5 is as to 10. Or if we were going in reverse, 10 to 5, 8 to 4, 3 to 6, or 6 to 3, excuse me. So, we have similar triangles right here. So on your little fill-in-the-blank notes, I would want you to fill in, or rather off to the empty side, or space, fill in the statement. The fact that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Okay, you're just re-emphasizing that. Also, fun fact, I think we talked about this in the last lesson, but angle A should be congruent to angle D because all triangles add up to 180. So if we already spent 90 for the right triangles, well then these are congruent, doesn't matter what they are. They could be 30, for example. Okay, if they're both 30, just throwing a number out there, then angle A has to be 60, just as much as angle D has to be 60. They have to be congruent. Okay, and the 30 and 60 was just an example. Bleep. Again, we're going to need to show that these proportions are going to be congruent. So A to B is to D to E, B to C is to E to F, A to C is to D to F. Okay, go ahead and take a second to write that down. And when you're done with that, we're going to put values in, and we'll see that indeed the ratios all equal 1/2. Each ratio is equal to 1/2. 3 to 6, 4 to 8, 5 to 10. All of it should be the same. And if it's not the same, then we clearly do not have the same shape, which means we don't have similar polygons. So again, I think this is another blank on your paper. The ratio of the sides is called the scale factor. In the example above, the scale factor from ABC compared to DEF is going to be 1/2. Now remember, that's when you go from the larger triangle to the smaller triangle. If you wanted to get bigger, we would simply multiply it by 2. Okay, this is multiplying by 1/2, or for some of us, it's just dividing by 2. Either way. Bleep. Oh man, my music stopped. Let me pause this real quick. Alright, fix it. I got me some jams back. No, I don't mean grape or strawberry jam. That's what we used to call music back in the day, back when I rode dinosaurs. Anyway, example 2, again, should be on your fill-in-the-blank paper. We want to write a similar statement for the figures above, which means triangle something 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 is similar to triangle something something something. Again, order matters. Make sure you keep things corresponding. Just take a hot second to write one. Alright, here we go. Bleep. This one's mine. We're going to say triangle GHJ is similar to KLM. Now I want you to write the triangle, or not the triangle, the angles that correspond to each other. Write separate statements showing which angles are congruent. Just take a hot minute for that one. Okay, bleep. So angle G should be congruent to angle K, as is to H and L, and J to M. Now go ahead and take another minute to do those proportional side ratios. Bleep. There we go. Should have had GHKL, HJLM, and JGKM. Okay, now we're going to substitute the numbers. Bleep. And as you notice, what is our scale factor? That's right. 1/2. Now remember, it's understood there's like an imaginary 1 up here, so don't let that, don't get lost in that. Also, more fun facts. Yeah, since root 2 is above root 2, those bad boys should cancel. So all you do have is 1/2. So these figures are similar. Bleep. Here's a riddle. Could you give me an example of 2 polygons where all the corresponding angles are congruent, but the ratios of the sides are not all equal? Nope. Nope. You're getting warmer. Ah, there we go. Good. Rectangles and squares. They're not similar, but the angles all are right. But these are different shapes, so they can't be similar. Try another riddle. Could you give an example of two polygons where the ratio of the sides are equal, but the corresponding angles are not all congruent? You see, now you're catching on. Squares and rhombuses. All are congruent except for the angles. So again, not the same shape, so they're not even similar. Good job. So take a second. I think this is on your fill in the notes. Instead of a good proportion to solve for AB. Again, you could probably just put an X in its place for when you set up your proportion. Now, I could show you one, but go ahead and try it, because as I said in class, you can set up probably 6, 8 million different ways to do this. Alright, here's one way to do it. I put 6 over 8, okay, see where they came from? Should be equal to AB, which again, you know, we said was X, so you could probably have an X on your paper, over 16. They're corresponding. So, cross multiply, you get 6 times 16 over 8. You know, use your calculator, bleep, bloop, bloop, and we get 12. Okay? Again, this could look different. You could pick different sides, but we should be getting the same exact thing. Okay? Bleep. Again, try to find some ratios for CD. Pause the video, give it a shot. Alright, here we go. Bleep. So, in this case, I took WX over AB. Should be congruent to YZ over CD. Substitute the numbers in. Again, this could be X for the sake of your notes, because you're looking for CD. Okay. Cross multiply, 2 times 14. As you know, we need to divide by 7. So you do the calculations. Boom, we get 4. Now this is one way to set it up. Here's another way to think about it. Could we take WX over YZ, notice they're from the same shape, and put it over A, B, and CD? Would you still get the right answer? Let's check. WX was 7. YZ is 14. AB is 2. CD is still our X. Ooh, boy. Cross multiply. 2 times 14 is 28. Sorry guys, the slides are not keeping up with me today. Oh boy. Something else be running in the background. Alright, let's try this again. 14 times 2 is 28. Oh, is me. Guys, I'm going to have to restart my computer. This is not keeping up with me. Alright, divide by 7, and if you notice, 28 divided by 7 is 4. We do get the same answer. So here's another fun fact we need to write down. The ratio of any two sides in one polygon is the same as the ratios of the corresponding sides in a similar polygon. So go ahead and write that down. You'll go ahead and pause the video. Alright, we're back. Boop. Here's a nice little example. I don't think I gave you space for this, but go ahead and, you know, write down the important stuff. Read the question. I would argue just copy down the picture. And obviously we're going to look for X here, but I'll go ahead and read it for you. A diagram of a rectangular foundations for a building and its scale model are shown below. If the length of the short side of the model is 10 inches, what is the length of the long side? So go ahead and pause the video and try to set up a good little proportion. Okay, we're back. Here's mine. We did 45 over 72. Should equal 10 over x. Cross multiply. We get 45x equals 720. Divide by 45 and we get 16 inches. Boom. Alright, let's see what else we got. So, we have a practice problem. Triangle ABC is similar to DEF. Question mark. Is it? Use math to show why or why not. So go ahead and pause the video, set up a proportion with the sides that are given, and see if they're going to be the same. Yeah, I hear you. Where's this side? You can use Pythagorean theorem to figure this side out. But let's just check these sides to see if they're even similar. If they are, then we'll check that one. Not similar, but congruent. Flipping between proportional and congruent, yeah, it gets pretty annoying, I know. Okay, blue. So notice, just using what was given, they're not similar. Okay, 1.4 is not congruent to 2 or equal to 2, so the ratios fall apart, so they're not similar. So there's no need to even find this missing side, because these other ones aren't even congruent, so there's no point in trying to find that third side. They all have to be congruent. Bleep. Ooh, look at that little kitty cat working hard on his homework, which means that's what you need to do right now. Similar polygons. State the polygons are similar. Here we're just checking ratios. Obviously, if it's a rectangle, then you don't really need to list all four for the four sides. You can just pick the two obvious ones. So we're going to do 10 over 15. And that should equal 14 over 21. So if you were to reduce these, again, if you're terrible at reducing, you could be using your Casio, but this would be 2/3. Okay. 14 over 21, that reduces to, that's right, 2/3. Oh my good grannies. Computer's not keeping up with me. That's what I get for trying to listen. Oh boy. That's what I get for trying to listen to music while we're recording these. 2 over 3. 2 over 3. Wonderful. So yes, they're similar. So you can check the rest of these, and the answer key is posted. Again, angles, check angles. Okay, they should be congruent. Doop, 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 doop. Polygons in each pair are similar. If they're telling you they're similar, find the scale factor of the similar figure to the larger one. This is important. Smaller to larger, which means your scale factor, I tried to write an S there, but Slate's not keeping up with me. Scale factor needs to be greater than 1 if it's getting larger. We talked about that before. I think that's nothing else to it. Just go ahead and practice. Y'all have a wonderful day. Here you go. Here's a smiley face that is messed up because my little writing slate is not keeping up with me. Alright, see you later.